Hey, what's up guys? So welcome back to a brand new video. Today we'll be trying to explore whether we can try and save data in the forms of an image. While the idea itself is not actually new, I figured that perhaps it might help some of you guys in your games. I know a while back there were games that would save levels on images, so you could just take a picture of the image and then it would read that out. But our use case is more about saving actual data in an image format, and then perhaps having your applications or games actually read that image and turn it back into data. So let's just take a look at how it works first, and then we'll go around and try to see how it works behind the scenes. So here I have a Unity scene setup. It's rather empty, with the only exception is the save tester. This is the script. So here it allows us to feed in a string value, and then this can be anything from JSON to a simple text. But for now we only have it as a text. And then we have a path, the path where it saves the actual data, and then a flag whether or not we want to use a colored image or a black and white image. So if I hit save and then I re-import this data, as you can see the image was generated, and now it's just this big black and white or rather grayscale image with a lot of black and white spots. And then if I were to remove the no, let's just keep that. Let me just click on load. As you can see, it just reads the text, and if I were to use the colored version and hit save, as you can see the image changes, and now it's more compact compared to previously. You can see the size difference, and I hit load, it again output the same thing. And if just to show you guys that it actually works, if we try to load a colored image using the black and white version, then you just get something non-readable. So yeah, same thing if you do it the other way around, it just becomes a text without meaning, really. So let's just see how the code works. So we've got the save tester. This is very simple. It just calls our save to image, which we'll see in a bit. And now this is the save image. We've got multiple classes and methods. The main class here is the save to image. We've got multiple methods, all static, because we don't really need to instantiate this class to use it. So here are the different methods that we have. We've got the actual save data and the load data. This is what we call to actually save the string to the image or load it back to string. And then for the save data, we've got two accompanying methods. One is the grayscale encoding and one is the color encoding. Same thing for the load data, decode grayscale and decode color. And then we've got two different methods here, encode and decode. We'll take a look at this in a bit. And then finally a get closest rectangle. So this allows us to get the actual size of the texture or the image based on the length of the encoded values. So then this is what allows us to generate the square. So the actual save data is very simple. All we do is take in a string and a boolean use color. Here we call encode using to save. If we expand encode, what it does is it gets all the bytes of the string. So we basically just convert it to a byte array, and then we just convert this byte array to floats. And then here we are just clamping it because colors is between 0 to 255. All we do is we divide each element by 255. So then this gives us a value between 0 and 1 float. So for instance, it can be 0.45 float, which would mean a certain float value, which when converted back would mean a certain byte value. And then decode is exactly this one's opposite. we loop through all the float, multiply them by 255 because here we divided them, and then we convert these floats back to bytes, and then we just use system.text.encoding, and then we just get string, pass in the bytes, and then we get the decoded text back. Okay, so this is pretty straightforward. And then once we actually get the encoded data, we pass this float into the get closest rectangle. Okay, this one takes an integer, and which refers to the length of the array, and then we just try and get the closest rectangle or square based on the provided number. So we just do the square root, and then we just seal the width and float the height, and then here we just try to trim the extra. And then one thing that I've done is I've added the padding. So here I've added 4 to the width and 4 to the height. So if you look at the data, you can see that there is a small space at top. The reason that I've done this is because I've seen that if you did not include this padding, then the messages, the string actually, might actually get concatenated. So only part of the string might get saved. So I found it that it's safe to just add a small offset, small padding to the width and height. This really goes a long way towards saving all of the data correctly. Obviously, you could play around with the algorithm itself or the actual padding size. You can have it lower to see what works for you. But here 4 seems to work perfectly fine. And now that we've got the texture size, we can go ahead and create a new texture as we would. So we just do new texture, texture 2D, and then here we pass in the width and the height. And then here is where we actually call either the colored encoding or the grayscale encoding based on whether or not we are using the color format. So for the grayscale encoding, it's very simple. We take in the texture size and the encoded data. We loop through all of the pixels in this texture. Remember, we've created the texture based on the sizes, which is also based on the array of the encoded data. So now what it does is, again, it just loops through all the pixels, and then at each pixel we try to get the index. So what we are essentially doing is we are converting the 2D space into a 1D index, and it's very simple. We multiply the current height index by the total width, and then we just add the current width to it. This gives us the index, which can be used in the encoded data. And then all we do is we check if the index is less than the encoded data, because there is the possibility that the index results in an index that is outside the array. If it is, then we just store a clear value here, which basically means 0 everywhere. And if it's not, so it's inside the array, we get the float value, and then we just set the pixel with R, G, and B in the same value. So value, as you can see here, that produces a gray value between 0 and 1. And then we just do new texture.apply and return the actual texture back. And if it's the colored encoding, it's the same thing. However, this time around, I'm using an index 0 here, and we are incrementing by 3 each time. Why 3? Because a color has R, G, and B values, and if you wanted to, you could use the alpha value as well. Sorry for that. Yeah, and then you'd have another value for the alpha, but we are only using the colored values. And then here we add the 3 every time, and then the exact same logic, but now this time we have 3 values, R, G, and B. R being the current index, the green channel being the index plus 1, and the blue channel being the index plus 2. And then again we check whether or not index plus 1 and index plus 2 is still within the bounds of the array. If it's not, we just add 0 there. And again, same clear. And that's about it for the encoding part. And then we just return the new texture. And for the loading of the data, it's the exact same thing. We get the width, we get the height, and we just make a new array by multiplying the width and the height, and then we call decode color and decode grayscale. Decode grayscale is the exact same thing as the encoding, it's just the reverse. So we loop through all of the pixels again, and then we just get the pixel color.r. Why? Because the grayscale, all the three values, all the three channels are the same. So it really doesn't matter whether or not we take the red, green or blue channel. Here we're taking the red channel. And then we use the same formula as above for the actual index. As for the decode colors method, it's the exact same thing. Again, use the index, loop through all the pixels. We check whether or not the index is still within the range of the decoded array. If it's not, we just return here itself. And then we just get the pixel at the current index, pixel color, then decoded data dot index, we just put the bar channel. Then we get the green and blue channel, which is index plus 1 and index plus 2. We check whether or not these are again inside of the array. If it is, then we just add it back to the array, and then we add 3 to the index, and that's about it. Now save tester. Again, we just call file.write all bytes. As for the load one, we just load the image as you would normally, and then we just debug the log. So that's about it for the actual coding. And if you hit play, then you can basically just save everything that you want. So hello YouTube, for instance, we could save. As you can see, the image is different this time around. And actually, let me open this inside of Photoshop so you can really see the bytes. But if we go ahead and load it up, as you can see, it saves hello YouTube, and hopefully that has loaded up. Here you go. And now if we were to zoom in, as you can see, here is the data. And if I were to write hello YouTube multiple times to represent like something very, very big, okay. Oh, actually, let's just write it on this version. We'll try to save the scene itself in the actual image. So I'm just going to come here, copy all of this, okay, and then just put it right there, hit save. Now this image should change. Let's just open it again, update, and fit on screen. As you can see now, there is way more data, and it's just a bunch of colors. Okay, and again, if we can load it up, you'd see that it represents the whole scene file. Okay, we can also save a black and white version. We import that, come back here and hit on update. As you can see now, it takes more space, and now it's just grayscale version, right? So if you guys found this video helpful, please be sure to leave a like, subscribe if not already. Also, do let me know, guys, what use case you can see for this kind of system. And also don't forget to check the link in the description so you can download this file and access the codes as well. And yeah, so I'll see you guys next one. Bye.